5-6. Now we're back from Christmas break. Everybody's raring to go. Learn some more math. And I'm glad of that. Okay, so here we go. Watch this. What I'm going to do is I'm going to draw line segment here, and I'll draw one that doesn't look like the same length. It could be the same length. It doesn't make any difference. But here's two different line segments right there. Okay, forms an angle. If I connected from here to here, I'd get a triangle, wouldn't I? All right, but what I want to do is I want to show you something. I'm going to copy and paste this. So copy, paste. So it's the same exact situation as we have right here. Same angle. This length is the same as this length. Would you agree? And this little one is the same length as this one right here because I copied and pasted. And the angles are exactly the same as well. Aren't they? Let's do this, though. Let's change this included angle. So right now I've got a side and a side. And I've got an angle and an angle that are equal, and that other side, another side. So far I've got side, angle, side. So if I connected from here to here and I connected from here to here, what kind of triangles would I have? I'd have congruent triangles, wouldn't I? Why? Because of side, angle, side. Agreed? But this chapter, well, not this whole chapter, but this part of the chapter anyway, is talking about inequalities. I don't know if you remember, but the last lesson we did, we talked about inequalities. Now we're talking about inequality. We talked about inequalities in one triangle. Now we're talking about inequalities in two different triangles. And you look at this, you're like, well, wait a minute, I don't have triangles here. But watch what I'm going to do. I'm going to take this. Now, right now, this angle and this angle are equal to each other. Would you agree? So what must be true about that third side then? If I connected, they would equal each other, wouldn't they? So what happens if I did this? What happens if I took this side right here? I'm not changing the length of it. All I'm doing is just, it's like on a hinge, isn't it? See that? It's like on a hinge. What if I extended it like that? Now, did I change the length of this? So I still have a side equal to a side. I still have a second side equal to the second side right here. But what did I change? I changed the angle. Now, if I did this, let's do this in a different color. Go this red. Watch, if I connected, like I said I was going to do earlier, from there to there, that would make a triangle, wouldn't it? Now remember, if this angle was equal to this angle, that third side would be equal to each other, wouldn't it? But what did I do? What did I do to this angle? I made it what? Made it bigger, didn't I? Okay. And so what if I connect from there to there? What do you think might be true about the third side of these two triangles? The one that's opposite what? Yeah, but it's what? Give me more specifics. Is it in comparison to this? It's larger, right? Okay, so the side that's opposite the larger angle is going to be what compared to this? I mean, you can just kind of look at it and see that this side right here definitely looks what? Well, not necessarily doubles, but it's what? This side right here is what to this side? It's bigger, isn't it? Okay, so the side opposite the larger angle, right, is going to be bigger than the side opposite the smaller angle. Now that kind of seems like what we did the other day. Do you remember what we did the other day?
No. Do you remember anything? It was literally last year.
It was last year.
Who remembers what we did last year?
Yes. It's going to be larger than the side opposite the smaller angle. Okay. So look at this. We had we talked about this. It's probably not the best triangle to do this on. Maybe I can. Yeah, let's really stretch the thing out. Okay. How would you draw that? Just draw a triangle. Obtuse triangle. Like right here. That's not hard. You can do that. Watch here. Look at this. This is what we did the other day. I think it was the last thing. Let me see. Yeah, this is what we did the last lesson, lesson 5.5. We said this, that this was our largest angle, right? And this was the smaller of the angles, and this was like the medium one. Okay, so I'll make like 3 arcs for the biggest angle, 1 arc for the little one, and then 2 arcs for the medium one. Okay, what did that tell us about the sides? Right. So if they told us this, if we were given that these angles were in this order, right, that was the biggest, that was the smallest, this was the one in the middle, what does that tell us about the lengths of the sides? That tells us which one is the largest side. BC. Which one is the smallest side? AB or BA. Okay, not because it just looks like it, but because if I told you this was the largest angle, this has to be the largest side because it's opposite the largest angle. But this was only dealing with one triangle, wasn't it? What are we dealing with up here? We're dealing with two different triangles, aren't we? All right, so let me just scoot this a little closer, about right there. So we're dealing with two different triangles. What did we start off with? We started off knowing that this side was equal to this one, and this side was equal to this one. Agreed? Now, when I first did it, they were equal to each other. But what did I do? This angle between, what do we call that? It's like a little bit fancier. Instead of saying the between angle, we say it's the what angle? The what? It starts with an I. It's the included angle, right? The included angle. Watch. Now look at this included angle right here. That one's pretty small compared to this one. This one's quite a bit bigger, isn't it? And I'll make it like a lot bigger. Is that all right like that? So that's a smaller angle. That's a bigger angle. So if you have two sides equal, two sides of one triangle equaling two sides of another triangle, and the angle between those two sides, one's smaller and one's bigger, what is that going to tell you about the opposite side? The opposite side of the smaller one is going to be what? Smaller than the opposite side of the bigger angle. Make sense? All right. So it's a little different. So the opposite side of the smaller angle is going to be smaller than the opposite side of the bigger angle. Make sense? So, for instance, if I said that this was like 30 degrees, and I said this was like 150 degrees, and I called this A, B, C, and I called this D, E, F. All right. So if I knew this was 30, I knew this was 150. Tell me something about AB compared to DE. AB is what? Less than DE. All right. That's basically it.
That's basically
150. I said it. It's 150. Well, that's what they're gonna ask you. They're gonna say compare the given measures. So that's what they're gonna do. They're gonna give you this, and they'll just leave a blank right there, and they're gonna say compare these two sides. So by giving this information right there, you look at it, and it's not because it just looks like it. It's because of our information. I've got a side, an included angle, right, and another side. But the included angles are not equal to each other this time. So they're not congruent triangles like we had way back in the past. But now one is bigger or smaller than the other one. So they're unequal, aren't they? It's an inequality. Now, let me tell you the name of this. Because we have a side, we have an angle, and we have a side, right? But the angles are not equal to each other. This is what a book that I taught out of for many years, and I think other books teach it this way as well. This book's a little different. I'm going to show you how I always taught it. And I always taught it as the side angle side inequality theorem. Okay? Side angle side inequality. So what does that mean? It means the two sides are equal to each other, right? These two sides are equal to these two sides. And what's true about the angle, though? They're unequal, aren't they? That's where your inequality comes in. Now, that's the theorem that I taught for years and years. But this book says it different. Remember what I said about this little thing right here? I said it's acting like it's on a what? Like on a hinge. Exactly right. Do you see that? So guess what they call it? The Hinge Theorem. Right. All right. I haven't seen, maybe other books do call it that. I'm not sure. But I know a couple books that I've taught out of. They never called it that. They've always called it the side angle side inequality. But this book calls it the Hinge Theorem. You can say this, and that's okay. But I kind of like this because it explains the theorem a little bit better, doesn't it? It says if you have two sides of one triangle equal to two sides of another, and you have unequal included angles, right, then the side opposite is going to be unequal as well. So if this is smaller, if this is your smaller angle, the side opposite is going to be smaller than the side opposite, the bigger angle. You get it? Do you see the difference between this lesson and the lesson that we did the last time? Because this only is one triangle, isn't it? We're just comparing the angles and the sides of one triangle. Whereas this one, we're comparing the angles and the sides to two different triangles. Sometimes it's obvious, but sometimes it's not so obvious. I mean, this picture, I made it obvious.
Like if they give you the numbers, then obviously it's.
Right, if they give you the numbers, because, I mean, they could have done this.
You see like 30 and 45, you're obviously going to know which is bigger.
Right, but sometimes it's not so obvious. Oops. Let me try to grab.
Are they not going to like give you the numbers though?
Well, we'll do a couple examples and I'll show you. Watch this. Let me just, let's see what goes on here. Let's do that, and then copy it again. Let's do that. So watch this. What if, let's listen please. Tim, I'm up here. Just because I take half a second to breathe doesn't mean you get a chance to talk. All right. Watch this. Right here, it looked obvious in that other one, right? Because I took this way down here. I mean, I made it obvious for a reason. But what if it was just like that? Okay. All right. Then it wouldn't quite be so obvious, would it? All right, just by looking at it. But if they said, what did I do to that angle? Did you notice what I did? I made it just a little bit smaller. So what do you want to call this? 20, let's call it 29 degrees, okay? So what if we had this? Now, my letters are all wrong, but you get the idea, don't you? Right. So then, let's call it DEF again. Right. Yeah, so, and if I wanted to compare them, AB to DE, and if I had this situation, look, this is bigger than this, right? So the side opposite the bigger one is going to be bigger than the side opposite the smaller angle. So I would say greater. Yes? Why don't you wait till we're finished here? All right. Let's see what else there is. There's got to be more to this, right? I think so. Oh, I know what this is. Watch this. We do this a lot in geometry. We do the converse. Remember the converse? So the theorem, this Hinge theorem, or the side angle side inequality theorem, said what? It said if I have two sides equal to two sides, and an included angle smaller than this or bigger than this, then we talked about the sides. But, watch this. What if I said that these two sides, AC was equal to DF, and BC was equal to EF, but I also told you that, let's see how I'm going to do this. We'll make this like, we'll make that real big, and we'll make that small. They don't do this in the book, but what is it? What do you think that tells you? It doesn't tell you they're equal because this is bigger than this, okay? And I'm just, again, we can't just go by looking at the triangle and taking a ruler out and saying, which one's bigger? Take a ruler and put it up to it. Because sometimes we'll draw it not to scale. Do you really have to go? So, you don't want to just do that. You want to go by the information given. So here's what's given. That these two are equal and these two are equal, but these two are not equal. Okay, this side is bigger than this side. What do you think that tells you about something about the two triangles here? Well, they're not congruent. That's true. That angle C is what? Larger or bigger, greater than what? Angle F. Everybody see that? Okay, it's the converse of it. So instead of saying two equal sides and an included angle, it's going to say two equal sides and a unequal side. You get it? So two of the sides are equal to two of these sides, but the third side are unequal. So what does that tell you about the angle opposite the third side? It's unequal in the same order. I had a book that used to say that. I don't know, does this book say that? No, it doesn't. But it used to say they're unequal in the same order, which means if this is bigger than this one, then this angle is bigger than this one. Or if this side right here was smaller than this side, then this angle is smaller than this side. Does that make sense? You sure? Okay. Yeah, I don't think that's really that big of a deal. Let's do an example or two. Is that all right? All right, here's your picture. We're going to compare WX to XY. Now, when I say I'm going to compare them to each other, what do I say? Either one's bigger, one's smaller, or possibly they could be equal to each other, I guess, too, right? I got three chances here. Either this is less than, it's greater than, or it's equal to. So let's look at the information. Well, I've got two equal sides right here. Or sorry, one pair of equal sides. Do I have a second pair of equal sides anywhere? Kenny, where is it? XZ, right, XZ. Right, because that's equal in this triangle, it's equal in this triangle as well, isn't it? Now look what I have. I got an included angle, don't I? But look at this one. 51 is smaller than 55, isn't it? I'll put 2 right there. So that one's bigger, that one's smaller. So what does that tell us about WX and XY? That WX is what? Is less than XY. It's as simple as that. It's pretty easy, isn't it? Yeah, it's not that hard. Okay, you just have to know what's going on. That's why I like to say the side angle side inequality theorem. Doesn't that make a little more sense than the Hinge theorem? I mean, you see the Hinge theorem because that thing moved around, but I like that better, the side angle side, because that's what I'm looking for. I'm looking for one pair of equal sides, and I'm looking for a second pair of equal sides, and then I'm looking for an included angle. But in this case, the included angles are not equal to each other, are they? Okay, they're unequal. That's why it's an inequality. Make sense? Let's do another one. Okay, here's a little picture for us. Let's label it. That's B and C, F and D. And they say that this side is equal to this side. And they say that this side is 3.6. And they say this side is 3. And here's what they ask you to compare. They compare two angles. Compare FCD and compare angle BFC. Alright, so let's take a look. Well, I've got one pair of equal sides. Do I have a second pair of equal sides anywhere? Yeah, that diagonal, FC, good. Now, I don't have any included angles, though, do I? Alright, but I do have a third side that's not equal. Everybody see that? So I've got this triangle right here. Here's two equal sides and a non-equal side. Got it? To this one. So this is bigger than this, right? 3.6 is bigger than 3. So what does that tell you? That the angle opposite, which is this one right here, has got to be what? It's got to be greater than the opposite, the angle opposite this other side. And that would be that one right there, wouldn't it? So that's the little one, and that's the bigger one, right? So what's this? FCD. Which one's FCD? This little one right here, right? So what do I say? FCD is what compared to BFC? It's less than. And that's your answer right there. And you got it by the converse of the side angle side inequality, or the converse of the Hinge theorem. It's just nice to know, because if we do proofs on it, then yeah, you'll need to know what the reasons are. Does that make sense? All right. Yeah, those other examples are pretty much just like what we finished. Let's see. Okay, let's do another one. Okay, here's your little picture here, and what they ask you to do is find the possible ranges, not just which is bigger, but the possible ranges of x. So x could be, that's a plus right there. X could be more than just one answer here. All right, it could be several different answers. We want to find what possibilities is it going to be. Brooke, what'd you say? Yeah, well, let's look at that first. Good idea. So I've got one pair of sides equal to each other. Where's the second pair? This is the third time today we've done that. EH, good. So we've got the second pair. All right, look at this right here. This third side is 11, this third side is 9. So tell me something about this 6x plus 15 compared to this 65. It's greater, right, than 65. Would you agree? So 6x plus 15 has to be what? Greater than 65. Make sense? Yeah? That's right. And it has to be, and it's less than a straight line, isn't it? Okay, so it also has to be less than 180 degrees, doesn't it? Go ahead.
How do we know that if the But also,
well, because if this is an angle in a triangle, there's no way that could be 180 degrees, because they have to add up to 180, right? So there's no way that could be 180. So what else could we say? We could say that this angle right here has to be what? So 6x plus 15 has to be what? Less than 180 degrees. Does that make sense? Because we just said it. Okay, this angle, and this angle right here have to add up to be 180. I can't have one angle in a triangle that's 180 degrees or bigger than 180. So it has to be what? If it can't be equal and it can't be bigger, it has to be what? Less than 180. Make sense? So that was the one that we tend to forget about right there. Okay, but that's what you have to think about. Now I've got two things, and now I can find my range. It's got to be bigger than this number. It's got to be less than this number. That's what I'm talking about by finding the range. Okay? So let's do the math on this. So 6x plus 15 is greater than, subtract 15, and that's what? 50, divide by 6, and I think they just do a decimal on this. 8 1/3. We'll just do it like that. 8 1/3. Okay? Isn't that right?
Yeah.
3 is 24. Yeah, 25 over 3 is the same as 50 over 6, isn't it? Right? Because that reduces to 25 over 3. Agreed? 3 goes into 25 8 times. 1 left over. Yes, that's basic arithmetic. Watch Khan Academy if you don't understand that. All right, let's do this one. 6x is less than what? Subtract 15, so that's what? 165. Divide by 6, so x is less than, I think that stays there. They say 27.5, so we can just say 27.5. Is that all right? So let's see how we're going to write this. Do you remember how we write this with just the x in the middle? Remember that? Yeah, so we put the x in the middle, and we put a less than and a less than. So we'll put the smaller number on the left, the bigger number on the right. So let's see if that works. So x has to be what? Less than 27.5. Where are you going to put the x? You're going to put it over here or over here?
27.
On the right. Well, the 27.5 you have to put over here on the right, won't you? Because it says x is less than 27.5. But it also says x is greater than 8 1/3. Now, on this one, you have to read it backwards a little bit. Do you see that? If you go from right to left, x is what? Greater than 8 1/3. And that's your range. So you could pick any number that's bigger than 8 1/3, but it has to be less than 27.5. You could put it in for x, and that's your possibilities for that angle right there. Does it make sense? Okay. Let's do this. Watch. Because if we did this, now we can't go right there. That'd be like 180 right there, wouldn't it? Well, actually, no, it would be right there. Right? Straight up and down. That'd be 180. So it can't be any more than that, can it? So it's got to be somewhere between here and here, right? It can't go straight up and down, but it can go like that, right? You can have a little tiny, you see that? That little bit right there. You could if you wanted to, but we're not going to do that. We'll just take it back down in here, right? It could be anywhere between there, right? Anywhere between here and here. That's what that value that we just found tells you that it could possibly be. Those are your possible values. Okay, that's your ranges. So they're going to ask for the range, and that's what they're asking for right there. You okay with that? All right. That was the toughest one right there, is to understand that, oh, I got to take that less than 180. All right, because that angle right there, it can't be more than 180. It can't be equal to 180. It has to be less than. We good? All right. Let me give you some problems to do.
Did we get to work on them in class?
Yeah, it looks like we have some time. Because we didn't have to go over any homework, since I didn't give you homework over the break.
Are we allowed to do it with partners?
Just do it on your own. Let's see. Honors Geometry. It's section 5-6. And it's pages 372 to 373. We're going to go 10 to 15. And then 17 to 20. That's not that many. Nah, it's not many at all.
It's 8 probably. They're probably not.
That's 9, I think, isn't it?
Yeah.
5 and 4. Okay, that's it.
No, it's 8.
What?
You said 17 to 20.
Yeah, that's 4 problems, 17 to 20. Because you got to count 17. 17, 18, 19, 20.
I always do 20 minus 9.
Right, but then when you do it like that, you got to add the one that you can't, because you have to count this. You're not just trying to find out how much you're in between it. Okay, that's all. Enjoy that homework assignment. Your first one of the year. Isn't that exciting? So make sure you do it. Your first math homework of the year.